hello everyone. Today in this session, we can learn about the introduction of the real numbers. Numbers are most important in our life. From morning to while going to bed, we have to use the numbers. Without numbers, we can't survive in the world. Either we are educated or uneducated, we must use the numbers. Before going to introduction of the real numbers, we can recapture the number system. First come to natural numbers. Natural numbers. So natural numbers are represented by capital N. So counting numbers are called natural numbers. Counting numbers are called natural numbers. That is 1, 2, 3, so on up to infinity. Suppose you want to buy 5 apples. How you will take 1, 2, 3, 4, 5 like this. So counting numbers are called natural numbers. It is represented by n. Come to whole numbers. Come to whole numbers. Whole numbers are represented by W. Represented by W. If we include 0 to the natural number, then they are called whole numbers. If we include 0 to the natural numbers, then they are called whole numbers. 0, 1, 2, 3, so on up to infinity. Now, next one, integers. Integers. Integers is represented by I or Z. So, the collection of negative numbers 0 and positive numbers are called integers. -3, -2, -1, 0, 1, 2, 3, so up to infinity. So in this 1, 2, 3, so on are called positive integers. Are called positive integers. Are called positive integers. So negative numbers -1, -2, -3 are called negative integers. Negative integers. Negative integers. What about 0? 0 is neither positive nor negative. Now come to positive integers. So positive integers, we can divide it into two parts. That is, one is the prime, another one is the composite numbers. We can divide it into two parts. One is the prime numbers. Another one is composite numbers. So prime numbers, what is the prime numbers? It has only two factors. Exactly. It has two factors. Exactly two factors. So, we can take for example, what is the prime numbers? Exactly, it has two factors, 1 and itself. For example, you can take 2. So, for 2, what is the factors of 2? 1 and 2. So, it has only two factors, which are called prime numbers. Take one more example, 3. What is the factors of 3? 1 and 3. So like these numbers we can call as a prime numbers. It has exactly two factors. Come to the composite numbers. Other than the prime numbers are called composite number except 1. So it has minimum 3 factors. It has minimum 3 factors. Minimum 3 factors. Suppose you can take 6. What is the factors of 6? 1, 2, 3, 6. How many factors are there? 4. You take 4. What is the factors of 4? 1, 2, 4. How many factors are there? 3. So like this we can define composite numbers. Now come to 1. 1 is the only number in the number system. It has only one factor. So 1 is the only number. 1 is the only number in the number system. In the number system having one factor. Having one factor. Having one factor. That means the number itself. That means the number itself. Now come to fractions and decimals. Fractions or decimals. Now take the number line. Here you can take 0, here 1, here -1. Okay, now in between 0 to 1 we have infinite numbers are there. In between 0 to 1 we have infinite numbers are there. Take one number 1/2. This in the form of fraction. You can write in the decimal form, that is nothing but 0.5. Already we know this. Again you can take here -1/2. What we can write in the decimal form? -0.5. So here we can call 1/2 is the fraction, 0.5 is the decimals. Come to the one decimal number. For example, we can take 1 to 123.4567. So in this decimal number 123 we can call integral part. So after the decimal point 4567 we can call decimal part. After the decimal you should not read 4567. After the decimal point you can represent single numbers 4567. So like this decimal number you have to take. So before the decimal we can read integral part. After the decimal you can read decimal part. Now come to the rational number. What is rational number? Numbers which we can express in the form of p/q. So which are called rational numbers. The numbers we can express in the form of p/q, where q not equal to 0, p and q are integers. Okay, rational numbers we can express in the form of p/q. Q not equal to 0, because if it is 0 it is not defined. P and Q are integers. Come to the irrational numbers. Irrational numbers. What is the irrational numbers? So not rational numbers is called the irrational numbers. The numbers which is not the rational numbers, which are called irrational numbers. Otherwise, the numbers which cannot express, the numbers which cannot express in the form of P by Q is called irrational numbers. Irrational numbers. According to the condition Q not equal to 0, P and Q are integers. Come to real numbers. What is the real numbers? We know already rational numbers and irrational numbers. The combination of rational numbers and irrational numbers are called real numbers. The combination of rational numbers and irrational numbers are called real numbers. Okay, now actually in decimal numbers we have the terminating decimal, non-terminating decimal. Now we will focus on the decimal numbers. So these decimal numbers we can divide into two parts. One is the terminating decimal. One is the terminating decimal. One is the non-terminating decimals. Non-terminating decimals. Now, what is the terminating decimal? Terminating decimal means after the decimal point, the digits are finite, which are called terminating decimals. For example, you can take 1 by 2, 0.5. Take 0.5. Here you can observe after the decimal point there is only one digit. So it is finite number. We can count the number. It ends by 5. Therefore, simply you can understand the terminating decimals is nothing but after the decimal point the finite number of digits are there, then they are called terminating decimal. Okay. Now, in the non-terminating decimals we have again two parts. One is the non-terminating recurring decimal. Non-terminating recurring decimal. And another one is non-terminating non-recurring decimals. Here you can observe in the decimal numbers we are divided into two parts. One is the terminating decimals. In the terminating decimals, so after the decimal point there are finite number of digits. So it ends by some number. It is countable, which are called a terminating decimal. You can take the example 1 by 2, 0.25. Okay. In the non-terminating decimals, we have again divided into two parts. One is the non-terminating recurring decimal, another one is the non-terminating non-recurring decimal. Come to the non-terminating recurring decimal. For example, you can take 1 by 3. What is 1 by 3? 0.3333 so on. It's infinite numbers. So after the decimal point, the number digit is repeating. It never ends. It is infinite numbers. So this you can write 0.3 bar. 0.3 bar. So it is the non-terminating and recurring. Recurring means repeating. So non-terminating recurring decimals. Okay. Now example, root 2 value, root 2 is equal to 1.414546 so on. Now here you can observe the numbers after the digits not repeating, and it is a non-terminating. It's a continuous. The numbers are continuous and it is not repeating the digits. So which are called non-terminating non-recurring decimals. So non-terminating non-recurring decimals we can call as a irrational numbers. Irrational numbers. Irrational numbers. Here you can observe terminating decimals and non-terminating recurring decimals we can say rational numbers. These two you can write as a, you can convert into rational numbers. Rational numbers. Because this you have to convert into a fraction. This is, you know, this is P by Q form. This is a rational number. This is also P by Q form. So terminating decimals and non-terminating recurring decimals we can call as a rational numbers. Non-terminating non-recurring decimals we can call as irrational numbers. Come to period. Come to period. What is the period? The digits which are present in the recurring part. The digits which are present in the recurring part. Okay, now come to the periodicity. Periodicity. What is the periodicity? What is the periodicity? The number of digits in the recurring part. The number of digits present in the recurring part. Present in the recurring part. For better understanding, we can take some of the examples. Then it is very easy to understand. Now come to the rational number. Decimal number, period and periodicity. Okay, now we can take the rational number 1 by 3. In the decimal form we know already 0.333 so on. This you can write 0.3 bar. Now here you can observe what is the period. The digits which are present in the recurring part. What is the digits which are present in the recurring part? 3. What is the periodicity? The number of digits present in the recurring part. Number of digits. How many number of digits here? Only 1. Okay, you can see here. Period means the digits which are present in the recurring part. What is the present in the recurring part? 3. That is the period. Periodicity. Periodicity is nothing but the number of digits present in the recurring part. How many number of digits present in the recurring part? 3. 3 into 1 digit. That is periodicity is 1. Now come to another example. 2 by 11 we can take. What is the 2 by 11? In the decimal form 0.181818 so on. This you can write 0.18 bar. What is the period now? The digits which are present. What are the digits which are present? 18. Now how many number of digits? 1, 2. Periodicity is 2. Now come to another example. 247 by 999. This is the decimal form 0.247247 and so on. This you can write 0.247 bar. So period. What is the period? The digits which are present in the recurring part 247. So number of digits 1, 2, 3. So you can understand this period and periodicity. Okay. Then here you can observe these decimals 0.3 bar, 0.18 bar, all these which is called pure recurring decimals. What we can call pure recurring decimals. Because after what is a pure recurring decimals? After the digits, all the digits are recurring. You can observe after the decimal 247 is repeating. Here 0.18 is repeating. Here you can see 0.3 is repeating. After the decimal point, all the digits are repeating. That digits we can call as a pure recurring decimals. One more is there, mixed recurring decimals. Mixed recurring decimals. What is the mixed recurring decimals? Take some example 0.1753. 53 is the bar. You can observe here after the decimal point some digits are not repeating, some digits are repeating. Here you can observe after the decimal point here 17 is not repeating, 53 is repeating, and some of the digits are not repeating, some of the digits are repeating. So these are the mixed. So these decimals we can call as mixed recurring decimals.